Hey everyone! Ready to dive into the world of engineering? Let's get started. How H-bridge circuits control motors. H-bridge circuits are essential for motor control, allowing precise control over direction and speed. By enabling current to flow in both directions, these circuits let motors rotate clockwise or counterclockwise, making them crucial in robotics and automation. From robotic arms to automated vehicles, H-bridge circuits play a key role in ensuring smooth and efficient operation. In this video, we'll break down how they work and how they convert electrical signals into mechanical motion. Let's dive in. Understanding the basics of H-bridge circuits. An H-bridge circuit is a configuration of electronic components that controls a motor's direction and speed. It gets its name from its shape, which resembles the letter H. The main components include transistors, diodes, and a power supply. Transistors act as electronic switches, directing current through the motor in either direction, while diodes protect the circuit from voltage spikes. By selectively activating different transistors, the H-bridge allows the motor to rotate in both directions, making it a fundamental component in robotics and automation. Understanding this basic concept is the first step in applying H-bridge circuits to real-world projects. Components needed for building an H-bridge. To build an effective H-bridge circuit, you'll need a few key components. 1. MOSFETs, metal oxide semiconductor field effect transistors, serve as the primary switches, controlling the flow of current. 2. Resistors limit current and protect the MOSFETs. 3. Capacitors stabilize the voltage supply for smooth operation. 4. A microcontroller, such as an Arduino, sends control signals to the MOSFETs, determining motor direction and speed. When sourcing components, it's best to use high-quality parts from reliable suppliers. You can find these components at online electronics retailers or local hobby shops. With the right parts, you're ready to build a solid motor control system. Wiring the H-bridge circuit. Correct wiring is crucial for the circuit to function properly. 1. Refer to a schematic diagram to visualize the connections. 2. Connect the MOSFETs in an H-bridge configuration, making sure the source and drain terminals are correctly aligned. 3. Connect the microcontroller to the gate terminals of the MOSFETs, allowing it to control the motor's direction. 4. Use insulated wires to prevent shorts and double-check connections before powering the circuit. Securing all connections properly, either by soldering or using connectors, ensures reliability and smooth motor operation. Programming the microcontroller. Programming the microcontroller is essential for controlling the motor. The Arduino IDE is a great option for beginners. To rotate the motor clockwise, you can use digital right pin 1, high, digital right pin 2, low. To control speed, use PWM, Pulse Width Modulation, analog right PWM pin, speed value. Once your code is ready, connect the microcontroller to your computer code using the Arduino IDE, and you're good to go. With the right programming, your motor will respond precisely to your commands. Testing the H-bridge circuit. Testing is an exciting step. 1. Power the circuit safely, ensuring the voltage matches the motor's specifications. 2. Connect the motor to the output terminals of the H-bridge. 3. Upload your control code, and observe the motor's movement. If the motor doesn't behave as expected, check for incorrect wiring, insufficient power, or faulty components. A systematic approach to troubleshooting ensures your H-bridge circuit works perfectly. Exploring advanced features. Once you understand the basics, you can explore advanced features. 1. Pulse Width Modulation, PWM, for smooth speed control. 2. Sensors like encoders or potentiometers for real-time feedback. 3. Experimenting with different motor types, such as stepper or servo motors. These enhancements can take your motor control projects to the next level. In this video, we explored H-bridge circuits, how they work, their components, wiring and programming. We also introduced advanced features like PWM and sensor integration for robotics applications. That's all for today. Stay tuned to TechBlueprint for more clear and practical engineering content.